On October 19, 2014, 30,000 people from all around the world ran the Beijing Marathon, many wearing masks. Smog blanketed Beijing on Marathon Day, but it was too late to postpone the event. The marathon is only one day a year, but air pollution in Beijing is a problem throughout the year. For that reason, the Chinese government will invest over $160 billion to reduce air pollution by 25% by 2017. Air pollution is measurable and can be predicted. There are at least 35 monitoring stations installed around Beijing, which collect data related to air quality on an hourly basis. Through the use of the monitoring stations, a metric called Air Quality Index, or AQI, can be measured. AQI ranges from 0 to 500 and measures the amount of dangerous pollutant elements in the environment and related health concern levels. AQI is volatile and suddenly reaches hazardous levels. However, air pollution can not only be predicted, but also influenced. The average AQI during Michelle Obama's visit to Beijing in March 2014 was much lower than on the days before and after her visit. Why? Because Beijing took measures to clean up the air. Using analytics, we can demonstrate that air pollution is caused by factories in cities surrounding Beijing and then brought into the city center by weather conditions and aggravated by car traffic, among other factors. Industry has been rapidly growing in China, with many factories around Beijing relocating to neighboring cities, such as Tianjin in the southeast and the surrounding Hebei province. Weather plays a key role in bringing smog into Beijing. Air quality in Beijing tends to be worse on days with wind coming from the south and east, which are where many factories are located. Wind speed also impacts air quality. We have discovered a strong inverse correlation between air quality and wind speed with a one-day lag. What does this mean? Well, suppose today is windy. All things equal, we would expect tomorrow's air quality to be good. That is because the wind disperses the smog outside the city. But suppose today is a calm day with no wind. That often means tomorrow's air quality will be poor, as smog is trapped in the city with nowhere to go. And now, let's take a look at a real example of how industry and weather together impact air quality. What you see is a map with green dots representing good AQI and red dots representing unhealthy air quality. To the left is an animation that shows both wind speed and wind direction. Take a look at what happens around 7 a.m. on May 15th in the cities surrounding Beijing. AQI goes above 100 everywhere but the capital, possibly due to factory emissions. But starting at 10 a.m., there's a steady wind coming from the southeast, and it doesn't take long at all for the pollution to travel to Beijing from its polluting neighbors Tianjin and Tansan. But then at 5 p.m., as people are leaving work and heading to restaurants or heading home, there's hardly any wind at all, and the smog stays trapped in the city. But look at what happens around midnight. The wind really picks up, traveling 16 miles per hour, 9 miles per hour, traveling east. After a very windy night, as people return to their offices at 9 a.m., air quality drops below 100 and improves substantially throughout the day. So what can we do to contribute to the conversation around air quality improvement? Airstock is developing a model to predict the causes of air pollution in Beijing and explore the social and economic impact of air pollution. Please feel free to contact us if you have any questions or would like to get involved in this project.